All right, welcome back to CEEN 101, Introduction to Civil Engineering. It's good to see everybody. It's good to see everybody's virtual faces. And we have a special guest who's going to join us this week. Before I get to introducing him, though, just a couple reminders about some things due in class. The next project is due 1 week from today. This is a natural hazards and infrastructure project. So this is where you guys get to go in and play a little bit with the 3D models that we've made using our drones and the images that we've captured from drones in some of the cities in central Italy. So this is a fun project. It's definitely hands-on, and hopefully you guys will learn a couple of things and come up with some interesting questions that you might want to ask. Do you guys have any questions about that project right now that that's on your mind that I might be able to answer for you?
We're doing that virtually, right?
Yes, yes. As cool as it would be to take the class to central Italy to explore those cities, alas, I do not have the budget to do that. But virtually, you can explore these cities as long as you'd like in 3 dimensions. And
when you were saying models, I was just like, wait, are these like models on campus or models on?
Nope, they're on your computer, 3D models on your computer. And so you'll think like Google Earth, but much cooler. Much
Thank
cooler.
you.
And you'll be excited to know that when you look at these models, we are in the process of working with BYU right now to make very high resolution 3D models of BYU campus. We've got everything down to even the statues, the faces of the statues and the writing on the statues. And we're going to be creating some virtual reality files with those as well. So if you guys have like an Oculus set or something, you'll be able to virtually put yourself on the BYU once those become available. So that's going to be really cool. Those will launch sometime in 2021. And so keep your eyes out for that. Okay, any other questions?
It says for the project that they want you to like source the information when you do like the first paragraph about the Italy earthquakes. Is there like a particular format you want us to source our information? Like, do you want MLA format?
I don't mind. At this stage in your education, I'm not going to be picky which format you use. Just be consistent, whatever one you choose. Good question. Okay, any other questions? Right now. All right, everybody. So I am going to introduce Dr. Grant Schultz. He is from the transportation specialty group here in our department. Dr. Schultz is a good friend of mine. I'm going to let him introduce himself and talk a little bit about his background. But he is the guy you're going to want to speak with if you have any questions about the area of transportation. So Grant, I made you a co-host, and you should be able to access all the controls that you need.
All right, well, we'll see how it goes. If things look weird, then I'm sure you guys will let me know. I'll pull up the chat here just so I can watch that as well. But yeah, so thank you, Dr. Frankie. I appreciate the opportunity to be able to be here today and talk about transportation engineering. A little bit of background about myself. I am originally from Champion, Alberta, Canada. I grew up on a farm in the middle of nowhere of Canada and somehow ended up specializing in transportation. Kind of joke about the fact that the average annual daily traffic on the street or the road next to where I grew up was about 5 vehicles per day, maybe. And somehow I ended up in transportation. Actually, I know how it happened. I worked on a road project in my area where I grew up, and was fascinated with the engineering side of things more than I was with the fact that I had the skill of driving a tractor, and so I got the job. But so I looked into that as I got home from my mission and became a civil engineer. So I am going to talk about civil engineering. I currently live in Mapleton, Utah with my wife, and we have 3 kids. Our oldest daughter and her husband and their 2 kids, so our 2 grandkids, actually live with us right now. They're in kind of a transitionary phase of life. And then I've got a daughter who teaches high school in Rawlins, Wyoming. And then my son and daughter-in-law are both students here at BYU. My son is studying manufacturing engineering, and my daughter-in-law is studying business. So that's a little bit about me. So let me start out here. I want to talk today to you about transportation engineering. As you are all aware, civil engineering is comprised of various specialty groups or different disciplines. In reality, all of those disciplines work together, but we do have kind of the specific areas that we all focus in on, and so I'm here to talk about transportation. So the first thing I want you to just kind of think about, if we were in the class, I just think about this a little bit, and we'll see kind of how you do towards the end of the class. But what do you think about when you think about transportation engineering? What do you know about transportation engineering and what that is all involved with? And then the most important thing, though, is how many of you are in civil engineering because you want to be a transportation engineer. And I am going to launch a poll here for you because I want to find out how many of you are in this class because you want to be a transportation engineer. You guys are pretty quick. We're up to about 130 of 155, so a few more people to vote, and then we'll see where we end up. Give you another 5 seconds. All right. Road construction does count to some extent. That's transportation. All right. Let's see what we got here. So here's the results. So 8 of you are going to get an A in this class, and the rest of you, you'll probably all get A's anyway, but that's good, so we'll see what you think at the end of this presentation. And then, of course, as you get into learning more about all the different disciplines, 74 of you said maybe, which, that's why we have this class, is so that you can find out what it is that you really want to do as a civil engineer. So the next thing I'm going to ask, let's do another poll here. I forgot I had this second poll right behind us here. How many of you used transportation today? It's kind of a little bit different answer than when I would give this in the live class, because a lot of you haven't potentially even left your apartment or your house today. So, all right, we got a pretty good number here. Question came in, does a biking count? You bet. A bike is definitely transportation. So, some of you, we had about a 50-50 split here, used transportation today. Some of you didn't. Yeah, somebody in the poll said you walked out of your bedroom, so I guess that can count. But typically, when we're meeting up here on campus, you all use transportation because somehow you got to campus today. And so that's an interesting, scenario that we all use transportation, which really, when you think about civil engineering, we all use civil engineering every day, whether it's transportation or water resources, or structures, geotech. We're all here. We're walking on the earth. We've got structures we live in, buildings we use. We go from point to point. We use transportation. We've got clean water and sewer. That's a great thing about civil engineering, and what really makes civil engineering awesome. So we got a few things in the chat here about electric bikes and walking, and do all these things count? Well, let's see. What mode did you potentially use? Or we'll break it down to maybe let's see. Here we go. What mode of transportation did you use? This could be, let's say, within the last week. Pick one of the modes that you used in the last week. Maybe the one that you use most often. All right, we'll go another few seconds here. About 92% have chimed in. So let's share these results. So the majority, 40%, well, actually 44%, majority in auto. Lots of people walked. We got about 9% biking. Still got 5% taking the bus. Well, somebody flew somewhere in the last week. That's good. I haven't flown anywhere since February, I think was the last time I was on a plane, and I usually spend a lot of time flying. So things have been a little bit different around my household as well. So those are a lot of the fun things that we can do. So these are what we call modes of transportation. So when you think about what you do each day, there's a lot of different modes of transportation, and we'll talk a little bit more about that coming up here in a minute. So transportation, what's its function? Well, provides for the movement of persons and goods from one place to another safely and efficiently with minimum negative impact on the environment. That's one of the things that we're trying to focus on, is minimum negative impact on the environment, and in having basically, an opportunity to provide a sustainable environment, a sustainable transportation system, so that we can all be a part of that well into the future. So when we think of, kind of the longer definition of transportation engineering, applying technology, scientific principles to the planning, functional design, operation, and management of facilities for any mode of transportation. So there's a lot of pieces to it. We think about all those pieces: planning and design and operations and management for all those different modes that we talked about, whether it's bicycles or auto or air. But all of that so we can provide this safe, rapid, comfortable, convenient, economical, and environmentally compatible movement of people and goods. So a big part of that, again, is people and goods. We're not just moving people, and even more importantly, we're not just moving cars, we are moving people, and there's a variety of different modes available for us to be able to do that. So here's just a couple of quick examples. You can see, moving from your home to an airport, taking an airplane, arriving somewhere at another airport, a bus or a rental car. All of these things, and getting from your point of origin to your point of destination, there's a lot that can be involved there. And if we look at goods, we've got water routes, we've got air routes, we've got rail, we've got auto or trucks, all these different things that are giving us the goods that we use every day. So all of that is also a big part of transportation. I don't know if anybody knows who this is. Anybody does, put it in the chat if you know who this is a picture of. Any guesses in there? Not seeing anything. Dog. All right, Spot from Target, Henry Ford, Orville and Wilbur Wright. Yeah, it's not Hitler either. So this is Horatio Nelson Jackson. He was an American physician, as you can see here, and an automobile pioneer. So the rumor has it that he was bet $50 that he couldn't drive his car across the country. And so he took whoever it was up on the bet, and he started a trip. And he drove across the United States, 4,500 miles in 63 days, 12 hours and 30 minutes, and it cost him $8,000 to get his $50 bet. Now, this, of course, was in 1903, when things were a little bit different than they are today. Here's the dog. This is a little close-up of dog Bud. And so here's the kind of transportation system we have today. You think you could make it across the United States in a little bit less than 63 days, 12 hours, and 30 minutes? I would hope so. But that was what he did. And that kind of became the start of the transportation system in the United States. That picture and the information that's on there was in the Smithsonian for a while. One year when I was in Washington, D.C., got a little bit of information on that. But there's a lot that's happened since 1903 in terms of transportation engineering. And so that's what I want to talk about a little bit today. When you think about transportation engineering, like I indicated, it's very interdisciplinary. There's a lot of things involved in transportation. We've got everything from on the on the right-hand side there: public policy, economics, human behavior, urban planning, art. We want things to be aesthetically pleasing in our transportation systems. And then if you look at the rest of these in green, those are kind of more the engineering and science side of things. So all those aspects that we talked about with civil engineering, structures, geotech, hydraulics, hydrology, all of those are part of transportation. Statistics, systems engineering, environmental engineering, surveying, graphics, geography. All those things tie into our transportation system. And so really, no matter what discipline you choose to specialize in civil engineering, should you stay in the major, you're going to, at some point, be involved in a transportation project. If you're going to be a structural engineer, you might design a bridge or a culvert or something associated with the roadway. If you're going to be a geotechnical engineer, obviously we have to understand the characteristics of the soil that we place our roadways on and what's going to happen there. Hydraulics, we have to understand what's going to happen to the water that runs off of this roadway. How's it going to run off there? Hydrology, how often does it rain? How much storm drain system do we need to design on that roadway? So all of these things tie together in transportation engineering. And of course, with that too, we see, some issues, challenges we have to look at. How do we provide service to rural areas, expand mobility, economic activities? We also have some of the environmental challenges that we face: congestion, delay. We've all been caught in congestion at different times, no matter what mode of transportation we're in. We have safety that we have a concern with. Just a lot of different things that we need good, strong minds to figure out ways to make things better all the time. We have intermodal transportation systems. So we've got, the front runner, the UVX. We've got a lot of different opportunities for us to be a part of an intermodal transportation system. So, the UVX bus, we're not using it as much now, but, the question I have for you, I have ridden on UVX, true or false? Try and do this in 30 seconds and see how we do. What does UVX stand for? Utah Valley Express, the Bus Rapid Transit, or BRT system. So yeah, I'm just interested in the actual UVX here in Provo. How many people have ridden there? So we got 90% with their votes in. Okay, let's see what we've got. Yeah, we got about 54% yes, 46% have not. Maybe some of you actually haven't even been to campus yet. So it is free. Right now, of course, with COVID and such, we've got fewer people riding, but we look forward to the day when we can safely get around everywhere again and be able to ride the UVX. Or we can look at other alternatives. I took this picture one day, was coming back from The Hague in the Netherlands, and kind of an interesting cross section here. We've got pedestrians, bikes, cars, and then over in that green patch over there that you can see it, and there's actually a train over there as well. So interesting, excellent, in my opinion, transportation corridor. So let's talk about a little bit about some of the different opportunities that we have in transportation engineering. Some of those are in the private sector or the public sector. We have field technicians, laboratory, office work, technical, sales, marketing, management. You know, that's transportation really is there's a lot of transportation professionals outside of just traffic engineers and transportation engineers that we might think about. So as you work your way into the civil engineering program, you know, of course, to become a transportation engineer is becoming a civil engineer, just with an emphasis in transportation. And, you know, we've probably talked about this in the class, 4 to 5 years to get your bachelor's and then a master's degree. Master's degree really gives you, from a transportation perspective, the courses that will really make you competitive in terms of a degree or a profession in transportation engineering. So a couple of things tied to transportation. So you all, I would think, are probably aware that the 300 level is where you get into the electives for each of the different disciplines. So 361 is the intro to transportation engineering. And then from there, you can kind of branch off into a variety of different courses. 461, which is the design elective, highway geometric design. We've got a course on urban transportation planning, one on traffic engineering, one on pavement design, concrete pavement design. From the traffic engineering one, you can branch off into transportation site planning and traffic simulation and analysis. So all of those things are part of the coursework that you would take in terms of looking at transportation. So there's a question in the chat. When you say competitive, are you talking about getting a job? Yeah, I mean, that's making you a competitive engineer in terms of getting a job and being able to have the skills that will help you to be able to get that job, or maybe that little better job than you might have otherwise gotten. So we have 3 faculty in transportation in the department. There's myself, and then Dr. McFarlane is our transportation planning engineer. Dr. Guthrie is pavements and materials. And the area that I work in specifically is traffic engineering and safety. I've also done a bit in planning over the years and had some experience there as well. I guess I will just kind of throw out there too, I didn't talk about this in my introduction, but so I've been here at BYU for 17 years. And prior to this, I was at the Texas A&M Transportation Institute. I got my PhD at Texas A&M University. Prior to that, I was a consultant in Salt Lake City for several years and in Boise, Idaho. So I spent some time in the consulting world, then went back to school, started into research, and then came to the university here. So let me just talk a little bit about some of the different aspects of transportation, traffic engineering. I'm going to talk a little bit about intersections and transit, and I'll talk just for a few minutes about planning and pavements as well. But one of the things that we look at in transportation, and one of the things that's kind of fun about being a transportation engineer, is everybody really is a transportation engineer in their own way, right? If you have a driver's license, you feel like you are a transportation expert sometimes. And so, you know, it's kind of fun. We get a lot of opinions that we have to work with and look at different ways to improve transportation engineering. So this is one of the things that we are always looking at ways to deal with is left turns. If we didn't have to deal with left turns, if everybody would just be like UPS and drive right turns and go in circles, then we would, you know, be able to move traffic a lot faster and safer, but people may not get anywhere, at least in the way that they're used to getting. So left turns is something that we're always looking at. And one of the ways we handle left turns is through different types of protected movements, permitted movements. This little picture on the side here is what we call a doghouse. It is shaped like a doghouse. Let me pull out my laser here. So if you really look at this, you got, you know, sides on each side here, and then you've got the roof that comes up. And so we can see here is our doghouse that we put our signal in. Now, that's how we used to do these signals, but we've now changed them to what we call a flashing yellow arrow. And maybe some of you have seen flashing yellow arrows before you're in Utah. Maybe some of you haven't been to Utah much and have seen these in different places. But this is basically the same thing as this doghouse, but what it does is it provides us opportunities to handle left turns in different ways. So we can do them as a protected left turn, which is when we have the solid green arrow. We can do them as a permitted left turn, where we have the flashing yellow arrow, and then a solid yellow arrow, of course, red arrow meaning we don't go. But those are some of the things that we do with left turns. In Utah, we like to do some other things with left turns, though. Those get into kind of some interesting intersections and intersection designs. So let me, let's see if we can, we'll see if we can make this work. This is what we call the continuous flow intersection. And I'm sure that you've seen this, and we'll see if my little link is going to work for us.
At UDOT, a major goal is to optimize mobility. And in Utah, the Continuous Flow Intersection, or CFI, has been used to optimize east-west movement. It all boils down to traffic signals, a crucial safety feature of a busy intersection. Traffic signals help drivers avoid potential conflict points. But a traffic signal also means you can't keep moving. And the more traffic there is, the more complicated the signals. A CFI reduces conflict points, which leads to more green time at the intersection. The most visible feature of a continuous flow intersection is the left turn crossover. This allows drivers to make their left turn before they reach the intersection, reducing conflict points. This feature alone has been proven to increase the number of cars moving through the intersection by up to 70%. But for a CFI to work at its maximum potential, drivers should be aware of all its features. In a continuous flow intersection, the fewer crossing lines of traffic, the better. So a CFI can include a bypass right turn, which allows right-turning cars to avoid cross traffic altogether. Sometimes a bypass right is omitted in order to keep local businesses operating. Avoiding business disruptions supports the economy. In such cases, right-turning cars must wait at a special light before proceeding. This light prevents conflicts with the left-turn crossover vehicles. Sometimes crossover left and right-turning drivers will converge at the same time. It's important that each car stay in its own lane as these vehicles come together. Sometimes drivers get distracted and drift out of their lane when turning, but this doesn't work in a CFI where each driver needs their own lane to turn safely at the same time. If the road isn't wide enough to receive all incoming traffic, right turns may need to wait for crossover lefts while other drivers continue moving. Once the crossover lefts are finished, right turns are free to keep moving. Continuous flow example of how UDOT keeps you moving.
All right, so there you go. There's one type of intersection. So I should have probably had a poll here to see how many of you have seen a CFI. But this, just kind of gives you that opportunity. One of the things, like I talked about, was left turns. Left turns become a real challenge for us in terms of, being able to accommodate all the different movements at an intersection. So what this does is brings that left turn movement further back so that these vehicles can turn left at the same time as the through movements. So this is a really good opportunity for us to move those left turns out of that intersection. One of the other things that we see or that we look at is what we call a diverging diamond interchange. This is another opportunity for us to take the left turns out. And I'll just kind of show you what happens here. So in this one, we come off the freeway, and we can either, you know, if we're going to turn right, we come up this ramp here. We can go on our right turn just like we normally would. Or we can come up here, you know, and in a normal intersection, we would come off of here and then we'd have a signal right here and we'd have to wait so we can cross over to our intersection. But here we actually turn left and we go in the wrong way. Now, some people get a little concerned about this. They don't like to go the wrong way, but it's the right way in some countries. But it's the right way to go here. And then we get to this point where we have an intersection. So at this intersection, now we have the opportunity to cross back over and continue on our way. But by bringing this, you know, driver to the left side of the roadway, we're able to avoid conflicts with these left turns, and all we have are these, what we call a two-phase signal at each side of the intersection. So two-phase signal has fewer conflicts. When we have fewer conflicts, we have a safer environment, and allows us the opportunity to provide for a safe transportation system. And these vehicles, they come off here, right, and they go onto the freeway this way. And we have the same thing coming off all of the other directions. So what are your thoughts about these? Let's see, we've got a lot of different comments in the chat box here. Got something about, yeah, so University Parkway and Sand Hill, that's the continuous flow intersection. That's what I showed you before. And the DDIs, these are the ones, like you said here, they flip the through lanes. We've got this, we move in the other direction. Traffic flow, I don't know the exact number of the increase in traffic flow here. One of the big reasons though is just it does improve traffic flow. It also improves safety, and it helps us out. The person who came up with this, his name's actually Gil Chlewicki. He's a friend of mine. He's been kind of excited about this, and these are taking, there's a lot of them throughout the country now. Let's see, Provost Center Street. Yeah, we won't talk about that one. That one does not do much for left turns and does some interesting things. Yes, where I drew the X's, there are traffic lights. All right. Anybody have any other questions about those two, CFI, DDI? How common is it to remodel older designed overpasses and intersections into these newer ones? That's a good question. You know, there's definitely a cost involved here. So usually there has to be a need, and that need is usually a safety concern or an operational concern. We do see that happen. Bangor Highway in Salt Lake City, that's one area where we went from regular intersections to CFIs. Now actually we've done just a standard diamond interchange, a tight, they call it tight urban diamond, because there's not a lot of room there because it's all built out. And so they utilized that space that they have and did a diamond interchange. Let's see, video on DDI decrease the chance of an accident by 50%. Yeah, because we've taken out those conflict points. I don't have anything in this presentation about conflict points, but that's a critical piece of that. And like I said, we won't talk about Center Street. You'll have to take 361 from me and we'll talk about it there maybe. Why is I-15 always under construction? We'll end with that question and we'll move on. Because we're engineers. We love transportation. We love construction. So I always tell my students that the orange barrel is your job security. So, you know, the main reason it's always under construction is because we're always trying to plan for the future and continue to build, and we've got limited budgets, but we take that budget that we do have and we have to kind of build incrementally because we don't have enough money to rebuild a whole freeway all the time, so we do it in segments. In Utah County, the current section will be done here in another month or two, and then focus will go somewhere else, probably up to Davis County. They've started some work up there right now. Salt Lake County is still doing some improvements, but we always see a lot of new information. And yeah, like Dr. Frankie said, construction equals a strong economy. So we love to see construction. At least I do. I hope as an engineer you will as well. And I will take this last one. This other question here is: a transportation engineer, do you plan new types of intersections? Yeah, I mean that's a big part of what you do if you work for a firm that's being involved in a project like this. You know, so when these projects come up and we have to look and say, okay, how can we handle these left turns? How can we remove these conflicts? How can we improve safety at that intersection? Then we start brainstorming ideas. We look at what projects, you know, have been done before, and then we come up with new ideas. Like I said, Gil Chilowicki, who actually came up with the DDI, you know, you come up with some of these ideas, and the first things we'll do is we'll simulate them. We'll use simulation to try and see what the impacts will be. And it's hard. It's hard to get somebody to actually build something that's never been done before. And so once you can finally get one and see how it works, then we see more and more coming forward. So a typical day involves, you know, a lot of coordination with your sponsors, coming up with design ideas, working with your team to come up with alternatives, and then choosing from all those alternatives which one of the projects you're actually going to build. So there's one other way that we look at left turns that's in this presentation, and that's through what we call a through turn intersection. So this one is a little bit different again. So here what we had was, this is right off of I-15. I kind of cut off I-15 over here, but here's I-15. We come off the freeway and you come to an intersection, and all of a sudden you've got this really heavy volume intersection. Now, if we get a lot of left turns turning at this intersection, whenever we have left turns moving, that stops our through movement, right? We can't move any through traffic. So what we have to do is look at other alternatives. So one of the alternative that you come up with here was to get rid of all the left turns here and run vehicles up here. And then they do what we call a through turn. They come around and then they turn right. Again, we're taking left turns out of that intersection. We still have through movement. You can see that there's a through turn over here. There's a through turn up here. And there's a through turn back here. So this, again, takes those left turns out of the intersection and allows us a different alternative. So this kind of came about as we've got jug handles, Michigan left turns. There's a lot of different names for how this kind of got started. They generally in the past were in more rural areas, and UDOT decided they would try one of these and see if it would work in an urban area. And again, it cleared up the traffic concerns and allowed for those to move more carefully. So yeah, this is in Draper, 123rd South and State Street, right off of I-15, and it's a lot of opportunities there. But yeah, these came about kind of more in the east, and we've kind of moved them over this direction. So those are just kind of some of the.
Dr. Schultz,
yeah.
Dr. Schultz,
Yeah.
sorry to interrupt. Just quickly for the class, will everyone please raise your virtual hands for roll and attendance?
Awesome.
Okay, back to you, Dr. Schultz.
Good. All right, so these are just some of the different types of things that transportation engineers do. Just some of kind of bringing us back to the things that we do here at BYU. This is a picture in our transportation lab on the second floor in the engineering building. We have access to all of the UDOT feeds that feed all their traffic cameras. We utilize those in a variety of different projects that we're working on. We've done different projects related to, like I've talked about, safety, and I'll talk a little bit more about that just in the few minutes I've got remaining. We're doing some work right now on connected vehicles in a way. We're looking at what's called dedicated short-range communication, between, we've done it between transit buses and signals, and now we're doing it between snow plows and signals, so that we can look at transit signal priority or signal preemption for snow plows, so we can keep them moving down the corridor. We're doing some work on automated traffic signal performance measures. We're working on traffic incident management, the different incident management teams that are out there that help us to clear up crashes after they occur on the freeway. So a lot of different projects, a lot of different things going on here at BYU. Just a couple pictures of the front runner, but you know, that all kind of ties into, there's a lot of, like I talked about, there's a lot of different ways, there are different areas in transportation. There's operations, planning and safety, and then materials. Safety, we have a lot of fatalities that occur. You know, our highway death toll is the equivalent of one major plane crash killing more than 100 people every day. So I spend a lot of time working on safety, trying to identify ways to make our roadways safer. And you can see we've kind of made improvements over time. Everything was coming down nice, and then we had a little blip, and now we're coming back down again. But there's a lot of things involved in that in terms of what we can do. If we look at, let's look at this one for a minute, we can see fatality rates. Our fatality rates have dropped over the years, but our numbers of fatalities are still pretty high, 35,000 a year. So that's one of the things I work on. Planning, Dr. McFarlane does a lot of work in planning. And basically what planning is trying to make these decisions of how big, do we make the roads? What are our needs going to be 20, 30 years in the future? We see all those construction barrels out there in projects, but those projects have been in the planning stage usually for 15 to 20 years. It takes that long to get through the process of planning and environmental projects, clearances, actually designing the project, getting the funding that we need, and then being able to get in and build that project. So we're always looking to the future, 20 to 30 years in the future, to decide what we're going to need. And then just kind of thinking about that, let me actually jump into here. All of that ties into our what's called a 4-step planning model, where we make decisions every day. We try to decide what kind of trip we're going to make and where we're going to go and what mode of transportation we're going to use and what route we're going to take when we do that. All of those things are really helping us to be able to make decisions on what's going to happen in the future. Question came up, said if it takes that long, won't the plans be outdated? Well, that's the thing. We're making projections to the future. Yes, we're always adjusting those projections, but they're pretty close in terms of what we're trying to plan and accommodate. And then the other piece of all this, of course, is, as we get our transportation system built, then we start to see it, start to fall apart a little bit. So we've got to make sure we're designing it appropriately and that we're, avoiding things like this. We all have seen this, and of course, none of us like this. So this is what Dr. Guthrie spends a lot of time working on, is how we can improve our pavements, create a better base and sub-base so that we can have our system, our pavements last longer. Because we really do want to avoid things like this, and we don't want to have sinkholes that eat up trucks. And a lot of that impact comes, we've got different types of vehicles, right? We've got small vehicles, we've got animals on the road, we've got large trucks. Those large trucks really cause a big portion of the damage, but they're so critical for our economy. So we've got to make sure that we can accommodate those. So, 3,000 or SUVs or 4,000 autos is the equivalent of one truck on the roadway. So we want to look at how that works. And then we get into, just a lot of different types of pavement damage, right? Just got a few pictures here. But Dr. Guthrie does a lot of research on that in looking at ways that we can improve pavements, that we can have a system that lasts longer and be able to have a successful transportation system. And there's a lot of cool things going on in that as well. Bridge, you talked about structures and bridges. those, you know, we've come in with some new ideas and ways to build structures as well. We actually build them on the side of the road and then we move them into place. And you know, with an automated bridge system, we actually lift the bridge up and put it in place. That's where we make sure that, or hope that we did a good job in our design so that it actually fits when we put it into place. So that's kind of a lot of it, just kind of gives you a real brief overview of what transportation is. There's a couple of other comments here in the chat. Let's see. Why do the plans take so long? Well, we have to just be planning, looking for the future. It doesn't necessarily take us 25 to 30 years to plan and, you know, design that entire project, but we're always looking to the future, and then we work in increments. We've got the long range plan, which is 20 to 30 years out, and then we have a 5-year plan. It's where we're actually doing design, getting the funding that we need to be able to make the projects, keep them in place. So we've got just kind of this tiered level of all the different projects. So these ones that are being built now, you know, at one time they were in the 30-year horizon. Now they're in that 5-year, and we're actually building them. Let's see. There is a lot of things that we have to look at there, like Dr. Frankie said. And looks like a lot of the other things. Any other questions? We just have a couple minutes left, but any other thoughts or questions? Let me finish off with this last poll. I want to see. After today's discussion, oh, whoops. Somehow I didn't change the question there, but the question is really, after today's discussion, how many of you want to be a transportation engineer? Sorry, just disregard that question there. I pulled it out of my other polls from my other class, and I must have forgot to change that one. So after today's discussion, how many of you really want to be a transportation engineer? We'll get up 40 seconds, and then we'll see where we're at. All right. Look at that, we're up to 22 now. So I gained, what, 14 converts to transportation. So we're good. All right, any last questions? Does a bridge fall under transportation or structural? Yes, it does. So really it's both. When you get involved in structures, there's a good chance you'll get involved in transportation.
How often do you have to move?
How often do you have to move?
Yeah, do you have to move, or is it mostly virtual?
As far as like the projects you work on?
Yeah.
Transportation engineers are actually one of those where you usually are working in the local area where you live. If you get involved in, you know, bridge design or something, that can be done from pretty much anywhere. But one of the fun things about transportation is you really get involved with people. You get involved with decision makers. You go to city council meetings. You go to planning commission meetings, and you're kind of the expert on the ground right there. So, you know, you don't necessarily have to move because there's always lots of projects in your local area, but you're usually working on something relatively local. How many people would work on one project? That could be, just kind of depends on the size of the project. It may just be a little team of 2 or 3 people. It could be a huge team like the I-15 reconstruction project. I mean, that's a conglomerate of, I don't even know how many, there's probably 4 or 5 different engineering firms involved and hundreds of engineers from all disciplines: structures, geotech, water resources, transportation, just a lot of variety. All right, well, I'll turn it back to you, Dr. Frankie. Thank you for letting me come.
Yeah, let's give Dr. Schultz a virtual hand clap. We appreciate you coming, Dr. Schultz, and sharing your expertise with us. If any of you have additional questions about transportation engineering, then I recommend that you reach out directly to Dr. Schultz or one of the other two faculty, Dr. McFarland or Dr. Guthrie, and just ask them your question. You know, we faculty, we love to address questions from students about our specializations. It's because it means you're interested and you might want to do research with us and study in our classes someday. So I'm sure Dr. Schultz will welcome your questions if you have them. So thank
Does that
you
mean
again,
that
Dr.
the
Schultz.
genetic disease that haunts my...
Uh-oh. Okay, someone's phantom taking themselves off mute. Let's not do that. Dr. Schultz, appreciate your time, and everybody appreciate you coming today. We got attendance, and so everything is good. Don't forget to complete your project by next week, and I will see you then. Thank you.
Yeah.